Okay, by the end of this video, I'm ready here. By the end of this video, a student will be able to derive sine rule. Okay, so let's start. Derive sine rule, state sine rule. Alright, so those are the two main things you need to be able to do by the ending of this video. So let's start. Consider a triangle. Consider a triangle right, and we label this triangle here A, B, C. So those are three angles of a triangle. This is also an acute triangle in the sense that none of them is more than 90 degrees and all of them are less than 90 degrees, so it's an acute triangle. Nevertheless, the grand total angle in the triangle is still 180 degrees. So this side is opposite, this side here is opposite to this angle, so we put here small c. This side is opposite to A, so we put here A. This side here is opposite to B, so we put here B. Okay, now I'm going to draw a height, and this height not necessarily will need to be halfway. It is just a perpendicular bisector to length AB, or just to one of the sides of the triangle. Okay, so that's a perpendicular bisector. So now I'm going to call this the height. So let's start with the deriving of the sine rule. So I have now sine rule. According to this, I'm going to put two equations. That the sine of angle A is equals to the height, which is the opposite side, over the hypotenuse for this part, which is B. Call it equation 1. And then we can say that the sine of angle B here has the opposite side H over the side BC, which is A. Call that equation 2. Now we will rearrange both equations to get H by itself. So the next step is as follows. We arrange it. Remember, this is equation 1. That becomes now cross multiply. We end up with the B sine A equals H, and for equation 2 that becomes A sine B equals H. Notice that both of them have something in common. What is it? The height. Both of them have the same height. So we do this. We substitute into our formula. Equate both of them equal. So we put now B sine A must equals to A sine B. Why? Because both of them have the same h and both of them equal to the same h, given that they're talking about the same triangle. So we need to get rid of the a's and the b's like this. We want it look more standard. So we divide both sides by b and then by a. Okay, or we can divide both sides by ba. So let me divide here by b first of all, or by BA instead, because we need to move them, the A and the B. So we divide here by BA and here by BA. Okay, since we're dividing both by BA on both sides to move the A's and the B's, notice that these B's will cancel with each other. These A's will cancel from this one here, leaving me with sine A over A equals sine B over B, giving now the concept that sine C should also be over length C, and that is now your sine rule. That's all to prove the sine rule. So just in case if you need to derive the sine rule, this is how you would derive it. Just in case if you need to use the sine rule and you don't remember what's the sine rule, this is how you would remember it. Remember, this concept here comes from the concept that the sine, recall, the sine of an angle is equals to the opposite side over the hypotenuse of that right angle triangle. That would be the right angle triangle, so that applies. That's the right angle triangle, so that applies. This is the concept, but remember, this is not a right angle triangle that we started working with. So that is our proof for the sine rule.